Hello viewers, in this session we will discuss about concrete mix design. What is concrete mix design? It is the calculation of the all ingredients and then to achieve the desired strength and durability with economically. It means you have to calculate all the ingredients like the cement mass, water mass, fine aggregate, coarse aggregate, admixtures like plasticizer and super plasticizer. And then you have to finalize the proportion of these ingredients to achieve the desired strength and durability with economically. So, concrete mix design may be defined as the art of the selecting as suitable ingredients of concrete and determining the relative proportion with the objective of the producing concrete of certain minimum strength and durability as economy as possible. So let us discuss about which are the objectives of mix design. First of all, we have to achieve the desired workability in the plastic stage. If you have make your concrete mass with the proper mix design, it has been observed that you will get the proper durability of the concrete mass in the plastic stage. If you have taken the improper proportions of the ingredients like cement and aggregates, so in that case you might have a problems like bleedings and segregations. So if you have done the proper mix design, you will get the higher workability in your plastic stage of the concrete mass. So this is the first object of the mixed design. Second one is to achieve the durability of the concrete mass. You consider a one important point. As a civil engineer, your task should not be completed within a 28 days after the achieving the strength of the concrete mass, because we are constructing the any type of the structure for the 50 years and 100 years. So you have to consider the one more important point, which is our responsibility, which is durability of the concrete mass, and it is possible with the proper mix design any environmental condition. And third point is to achieve the desired minimum strength in the hardened state. This is the most important point. If you are constructing the particular structure and it requires M20 grade of the concrete, M40 grade of the concrete, M15 grade of the concrete, whatever you require, so you should consider that you have to make the concrete mass with the proper mixed design. So this is the calculation of the ingredients and the finalize the proportion of the all the ingredients like the cement, fine aggregate, coarse aggregate, water mass, admixtures, fly ash and super fly ash. So all the ingredients you have to finalize, and then you have to finalize the proportions of the all the ingredients. Then you can get the minimum desired strength at your site. So it can be possible with the mixed design of the concrete mass. So this is the one of the important point, and I would like to one more point, which is that it should be economically. It doesn't mean that you are adding the more cement mass to achieving the higher grade of the concrete and achieving the higher durability and achieving the higher workability, but you are not making the economic concrete mass. So the structure will be uneconomic. So you should also consider the one more important point, which is the it should be economical also. So let us discuss about symbol of M20. You might have a question arise that what is M and what is 20? M is refers as a mix, and what about the numerical value, which is the 20? What it indicates? It indicates the 20 Newton per mm square of the minimum compressive strength at the end of the 28 days with the 150 mm by 150 mm by 150 mm cube mass. So before the starting the any type of this structure, you have to find out the hardened property of the concrete mass. It means after the mixed design, you have to do the trial testing, and in the trial testing you have to identify the compressive strength of the concrete mass. So if you are making the M20 grade of the concrete mass, you have to ensure that your concrete should give the 20 Newton per mm square of compressive strength at the end of the 28 days with 150 mm by 150 mm by 150 mm cube mass. If you are making the M100 grade of the concrete mass, it means you have to assure that your concrete should give the minimum compressive strength of 100 Newton per mm square at the end of the 28 days with the 150 mm by 150 mm by 150 mm cube mass. This is the standard mold size of the 150 mm by 150 mm by 150 mm, but it shows you the compressive strength of the concrete mass at your existing site. But we have to assure with this standard mold. But this numericals value 20 or 100, this will give the compressive strength at your existing site. So let us discuss about basic consideration for mixed design. So there are the main four consideration you have to consider for our mixed design. We will start from the cost. Which are the cost will affect to the mixed design. In that case, I would like to add first one is the material cost. Material cost is the main costing that will affect to the concrete mixed design. I am giving you an example. If you are design a concrete mass with only the cement mass, but cement is the costlier than all the ingredients, so this mix become the costlier. But rather than you are adding the pozzolanic materials like fly ash and others, so in that case they may be decrease the cost of the mix. So in your design consideration you have to consider this material cost while you are designing the particular strength of the concrete mass. Second one is the equipment cost. If you are mixing the concrete mass with the hand mixing, or you are transporting from the manufacturer to your existing site, so equipment will be utilized and there will be effect to the equipment cost, and you have to consider also this cost for your concrete mix design. And third one is the labor cost. So we require the labor for the concrete mixing, transporting, placing and finishing of the concrete mass. So you have to consider while you designing the concrete mix design. Second point is the specification. In the specification, you might have many types of this specification while you design the particular type of the concrete mix. For example, minimum compressive strength. You are designing for the M20 grade of the concrete mass. So your focus should be you should achieve the minimum compressive strength of the 20 Newton per mm square at the 28 day. And if you are designing for the M50 or M100 grade of the concrete mass, your target should be M50 Newton per mm square of the compressive strength and 100 Newton per mm square of the compressive strength at the end of the 28 days. It means there may be different quantities requirement for the designing for particular strength of the concrete mass. So this is the most important specifications. And second one is the water cement ratio. in the concrete mix design, the water cement ratio is one of the important point because the water cement is directly affected to the workability and the strength of the concrete mass and the durability of the concrete mass. When you are using the lower water cement ratio, in that case you will get the higher strength of the concrete mass and you will get the high durability of the concrete mass. And if you are adding the more water mass, in that case there may be effect to the strength of the concrete mass as well as the durability of the concrete mass. So water cement ratio, which is also important specification while you are designing certain strength of the mix. And the third one is the maximum aggregate cement ratio, because the aggregate cement ratio, which is also important term for the workability as well as the strength of the concrete mass, because the particle size will affect to the workability of the concrete mass and this will also affect to the strength of the concrete mass. And last point for the specification, which is the density of the concrete mass. This specification is very useful in the dam construction because density of the all the ingredients of the concrete, and we can say the density of the concrete mass will affect to the dead load of the mass construction work. Third point is workability. This is the most important consideration for the concrete mix design because the workability is the edge of the mixing, transporting, placing, finishing homogeneously without affecting segregation and bleeding. For achieving the higher workability, you cannot add the more water mass because if you are adding the more water mass in your concrete mix design, in that case this will affect to the strength of the concrete mass as well as the durability of the concrete mass. Rather than you can use the plasticizer and super plasticizer for decreasing the requirement of the water mass. So you have to consider this point while you are doing the concrete mix design. And fourth point is strength and the durability. In mixed design, the water cement ratio will directly affected to the strength of the concrete as well as the durability of the concrete mass. You can achieve the higher strength and the durability of the concrete mass with the lower water cement ratio, and if you are adding the more water mass in your concrete, in that case this will affect to the strength of the concrete as well as the durability of the concrete mass. So this specification you have to consider while you are doing the concrete mix design. So these are the basic consideration we have to take when we are doing the concrete mix design. Now let us discuss about grade of concrete. As per the Indian standard 456/2000, the table has been given. You can see on the table shows this first column shows the group of the concrete like ordinary concrete, standard concrete and high strength concrete. And second column shows grade designation like M20, M15, M20 up to M100. It means ordinary concrete covers these three grades of the concrete like M10, M15 and M20. As we earlier discussed, what is M10? It means your concrete will give you the minimum compressive strength, the 10 Newton per mm square at the end of the 28 days. What about the M100 grade of the concrete mass? It means the concrete mass will give you the minimum 100 Newton per mm square at the end of the 28 days. So you can see this all the grades M10, M50 and M20 will cover with the ordinary concrete, and in the standard concrete M25, M30, M35, M40, M45, M50, M55 and M60. This grade is covers in the standard concrete. If we talk about the high strength concrete, it will start from the M65 and will reach to the M100. It means you can see groups are divided in the three types like ordinary concrete, standard concrete and the high strength concrete. And you can see the grade designation in the second column. If we talk about the characteristic compressive strength with the 150 mm by 150 mm by 150 mm cube at the end of the 28 days, you can see the M10. This will shows the 10 Newton per mm square at the end of the 28 days. If we talk about the M100, this will give you the 100 Newton per mm square at the end of the 28 days. This table has been given in Indian standard 456-2000, and if we talk about the minimum grade of the concrete mass you should consider in your site for the plain cement concrete PCC, you have to use at least 15 Newton per mm square. It means you have to use M15 at least for PCC. And if we talk about the RCC, reinforced cement concrete, in that case you have to take at least 20 Newton per mm square. It means you are constructing the RCC elements. In that case you have to take at least M20 grade of the concrete mass. Let us discuss about nominal mixed concrete and design mixed concrete. You can see on the table on your screen the nominal mixed concrete is the wide use of the concrete as construction material has led to use of the mix of fixed proportions which ensure the adequate strength, and these mixes are called nominal mix because this method is adapted to simplify the finalize the proportion of the concrete mass of the ingredients of the concrete mass. So in your site, the wide variation of the strength can be accepted for your construction element simplifying. So in that case, it can be possible that you can use this nominal mix construction. It means you can use the simplifying proportion for the particular grade of the concrete mass. You can see the M5, it means 1 gem, 5 gem, 10. What about 1, what about 5 and what about 10? These are the proportion. For first part, 1 is indicates for the cement mass and 5 shows for the fine aggregate and the 10 shows for the coarse aggregate. It means one part is required for the cement of the total volume of the concrete mass or mass of the concrete mass. And if we talk about the 5, it shows that 5 part is required for the fine aggregate of the total volume of the concrete or mass of the concrete mass. What about the 10? 10 shows the 10 part is required of the coarse aggregate for the total volume of the concrete or the mass of the concrete mass. It means 1 is a cement, 5 for the fine aggregate and 10 for the coarse aggregate. It means if you want to require the M5 grade of the concrete, in that case you can use 1 part for the cement, 5 part for the fine aggregate and the 10 part for the coarse aggregate. You can mix concrete with the proportion of 1 gem, 5 gem, 10 for achieving the M5 grade of the concrete mass. So you can see the different grade shows in the table. You can see the M20, it means 1 part required for the cement, 1.5 part for the fine aggregate and the 3 part for the coarse aggregate. So you can see the different nominal mix you can use for the different grade of the concrete mass. So this nominal mix is also called the standard mix, and quality control is not considered because this is adopted to simplify the finalize the proportion of all the ingredients of the concrete mass, and the trial mix are also not essential, and the trial is not done in this method. So this is the simple method, and this all about the nominal mix concrete. If we talk about the design mix concrete, if you are doing the larger project, or if you are concreting in the important element of the concrete mass, and if you are doing the high-rise building or any important structure, in that case the design mix concrete is required, because in this method you are calculating all the ingredients with all the properties of the ingredients, like the physical properties and the chemical properties. Then you are finalizing the quantity of all the ingredients, and then you are finalize the proportion of the all ingredients perfectly with the trial based method. And then you are also consider the control mix, and you are also consider the quality in this method. So the nominal mix produced under the quality control, keeping in view in the strength, the durability and the workability, is called the design mix. It means this also called the control mix, and you have to design of the mix design with using of Indian standard 10262 2009, and you also require IS 456 2004, finalizing all the ingredients of the concrete mass to achieving the certain strength of the compressive strength of the concrete mass. So if you want to M20 of the concrete mass in the design mix, so you have to calculate all the ingredients, and then you can finalize the proportion of the M20 grade of the concrete mass in the design mix concrete. So there is a difference between the nominal mix concrete and design mix concrete. I'm giving you example. For example, you are making the concrete mass for the M20 grade of the concrete. In the nominal mix, you are using the simplify 1 gem, 1.5 gem, 3. And in the design mix, you have to calculate all the ingredients. So this is all about the difference between nominal and design mix concrete. Let us discuss about advantage of quality control. After the mixed design, you can finalize all the quantity of the ingredients of the concrete mass, and you can change the quantity of the materials like cement, and in second case you are using the cement plus fly ash. So locally available material you are using the higher quantity with the proper mix design, so there will be decrease the cost of the concrete mass. After the designing of the concrete mass, you are using the certain quantity which is required for the particular strength of the concrete mass. In that case, there will be decrease the wasting of the concrete ingredients, and you are using all the ingredients, and you are utilizing all the ingredients efficiently. So the material cost will be decreased with the proper mix design. If we talk about the maintenance cost, if you are doing the proper mix design and you are concreting with the proper mix concrete mass, so in that case there will be required the less maintenance for the particular concrete mass. So overall maintenance cost will be decreased. And third one is reduce delay in the construction, because you are finalizing all the ingredients of the concrete mass. It means you are finalizing the requirement of the quantity of the concrete mass. So in that case, you can store all the ingredients before your activity started, and after the mixed design of the concrete, you can finalize all the activities, and you can manage the material inflow and the outflow, and you can also manage for the labors, and in that case you can reduce the delay of the construction duration. And the last one is a safety and serviceability. As a civil engineer, our responsibility is to construct the safe structure in our field, and it is possible with using of the proper mix design, because with proper mix design you will make the proper concrete mass, and you will also get the certain minimum requirement durability of the concrete mass. So safety and serviceability is one of the important point as the engineering point of view. So after the quality control with using of the proper mix design, you can achieve this all the advantage with quality control. Let us discuss about which are the methods for the concrete mix design. There are the many methods you can adopt the finalizing quantity of the ingredients of the concrete mass, and you can finalize the proportion of the ingredients of the concrete mass. So which are the methods for the concrete mix design? First of all, IS method, Indian Standard Method, and we will use the IS 10262 2009, IRC 44 method, ACI method, arbitrary method, UK method, British method, fineness modulus method, and surface area method. You can choose any one for the particular mix for the concrete mix design. So this is all about the introduction of the concrete mix design. Thank you.